Namaste. Today we will be studying game theory, not only just game theory, but its application in modeling, its application in real world problem, how the real world problem are solved through game theory. Before we start its application, first we need to understand what is game theory actually. There are two words, game. Game means what? Can we define game? Not by just linguistic terminology, but by the mathematical terminology. Yes, this strange phenomena comprises with the theory. If any game is studied through mathematics, then this game is not just game, but this game is transformed into mathematical game. This is a game theory, but how game theory is applicable, how the game theory is significant for solving the real world problems. We can see here prisoner's dilemma, how the game theory is applied for studying the prisoner's dilemma. Snowdrift, we know that in Himalaya or any particular region where snow falling is there, but the road is blocked by snowdrift. How the continuity of transportation is possible? This is also the problem, real world problem deals with game theory. Closed bag exchange, snowdrift also deal with revolutionary biology, or what are the biological problems also deal with this snowdrift or chicken game problem. Closed bag exchange, this is the economical problem. It means game theory is just not only based on game and its mathematical studies, but its real application transformed the solution into the optimal solution. Yes, now we imagine about games, not only just game, but also you can include sports. You can see here there are varieties of games, chess, carom, ludo, poker, but not only you bounded with just these games, but also you can include sports, cricket, football, volleyball. What are actually these? How these games are defined? How these games are formed? How these sports are created? It is just a natural creation, or it is created by some phenomena, or this is only for entertaining? Maybe there are various cases, but actually game is just not for enjoyment or entertaining, but we can also apply the game through the mathematical theory into various applications. Here we see chess. You know, there are two players are required in chess. We know carom, at least 2 players are required and maximum 4 players. What do you mean about the players? The players definitely facing the situations, conditions. What will the moves, what will be the actions taken by the players? There is win, there is lost, there is winner, there is loser. How the winner is justified, how we declare the loser, how the winner play the game for winning. Nobody play the game for losing. Why? This beauty, these questions is really exciting to understand the game theory not by only game but through mathematical game. As we studied the beauty of this game not only by the rules and laws of the games, but mathematical or scientific rules are also involved in studying the games. But how it is introduced, how it is existed? Actually, the game theory, the real discoverer of the game theory is Professor John von Neumann in 1928. Actually, he solved a Brouwer's fixed point theorem. This is the pure mathematical part. This is a pure mathematics, belongs with real and functional analysis. Brouwer's fixed point theorem he defined from continuous mapping into convex compact set. This solution method is definitely a pure approach, but this approach is applied in game theory, and Neumann and Oskar written a joint paper. This becomes the fundamental breakthrough in not only the science but every field of human existence: computer science, economics, biology, commerce, industries, politics. Whatever we are facing as the human problems, everywhere game theory can apply, everywhere we can see the game theory. And in 1994, Professor John Nash from University of Princeton, United States, received the Nobel Prize of his breakthrough theory of mathematics and its application in economics, received the Nobel Prize in economics. John Nash or Nash equilibrium. These are the very beautiful understanding platforms in the journey of game theory. A Beautiful Mind. This is the film based on biography of Professor John Nash. Nash equilibrium not only applicable in just game but various computer applications also. Next, we can see here game theory is dominated in various branches of science and arts and technology: economics, revolutionary biology, computer science, social science, military science, ethics, philosophy, economics, commerce, industries, production, consumer behavior. Whatever we are facing in current scenario for developing our human existence and our extreme thought through these sciences, game theory is playing a leading role, because through the game theory we can find the optimal solution rather than just solution. But how it is possible? Therefore, we must know about how the game theory applies. What is game theory? Game theory is the study of game through mathematics. It means there are situations, there are the players interact to each other, then what they will do. There are situations, how the situations treat as entities. Actually, these entities are called players, and players are not just sitting there, but they involved in the game. because the game is played by the players. Then players take the actions. How many possible ways? How many probabilities? What are the options the player have to move the next step? Maybe that affect each other. This is the beauty. The nature of players: 2 player, 1 player, 10 player, 11 player, it is depending on the context. Hence, we can see here game theory consists the 5 main vertices. First, rule of the game. Second, outcomes, because declaring the winner and loser with the base of outcomes. The payoffs. What do you mean by payoffs? It is the mathematical terminology or matrix or array representation of their decisions, their moves, representing by the array or matrix. Then the elements are represented as the payoffs. Uncertainty of the outcome, because nobody can predict who will be the winner, nobody can predict what will be the outcome. This lies with the uncertainty. Decision making, how the players are decided, the moves, what are the decisions taken by the players, what is the decision, the decision is true or false, how we can justify. This all carry with decision making, but you know that there is no cheating allowed, because if cheating is there, then the rule is chaos, the rule is clash. Therefore, no cheating is defined here. Here already we studied the basic concept of the game, but how we introduce the game theory? Very simple, it is a complete set of rules describe a game. But what are the role of play and players? The play and players comprising with the situations called positions. A player has to make a decision, because if they know the rule, if they confident about the rule, then definitely the rule transforms into the action or moves. The action or move is not a random process, it is depend on a sequence or particular practice. Then definitely we have the particular move can be decided the outcome. This is not same as strategy, because there is strategy, but the strategy also carries several conditions, several cases. How we deal these all scenario, all vertices, all nodes into the probable outcome. This is the real beauty of game. Now we can see football, chess, poker or any game. We can imagine about any game, just like a chess. One player moves, then after next player put his moves. What do you mean? Because there is sequence is defined, but in football there is no sequence. In hockey there is no sequence, or any other game. Sequence means definitely a rule is there. It means the game can be played through 2 main characteristics: sequence game, just like a chess, and simultaneous game. It is depend on you. Simultaneous means there is no sequence is defined. You can imagine how many games are there lying with simultaneous and lying with sequential game. In general, we do not have the sequential game in real world. Can we see? Just you check in the real world problem, the games classified in which category, simultaneous or sequential. It is very interesting because if we defined or classified the game's type, then our objective is clear or more crystal clear than the existed. Here we see there are the varieties of conditions, there are many ways define the game. Zero sum game, you means there are the payoff matrix. If one has yes, then definitely another has no option. It means plus 1 and minus 1, the resultant is 0. Plus a minus a, the resultant is 0. 0 and 0, the resultant is 0. Minus 1 plus 1, the resultant is 0. This is total defined with the payoff matrix or zero sum game. We can confirm the complete information the player have. We can confirm the player's perfect information, how they ensure about his moves as the perfect information behind that move. These random moves, these maybe sequential moves, what are the what are the conditions involved in their moves. Therefore, the classification of games is very important through the characteristics of information, complete, perfect, zero sum or any random moves. Here already we have studied the zero sum games. Zero sum game is nothing but sum of the payoffs. It means plus 1 minus 1 0, 0 and 0 is 0. Then a player can have a positive payoff only if another has a negative payoff. Very contradict. It means first one put his positive decision as the plus, then definitely the same quantity occur by the other player, that is the minus. It means poker and chess, you can see examples of zero sum games, but in general in real world problem very rarely we found the zero sum game, because in general the real world problem lies with non zero sum game. Therefore, the modeling is very important. Now, we compact our decisions, our explanation. Communication is permitted, it is very important because only players are involved. Then how the role of communication here? Communication by the other one or communication by the each other? It is very important, but communication is the very important parameter in the game. Next one, cooperative or non-cooperative. It is a wonderful thing because the theory of game is introduced not only by the Professor John Nash, not only by the Professor John von Neumann, but the real beauty of the game theory appeared through the cooperative on non-cooperative, because this is the conditions of equilibrium. What are the real meaning of cooperative and non-cooperative? These are the natural questions definitely carried in the modeling process. Therefore, classification of game is very important. If you are unsure about its classification, then definitely a perfect model to be appeared. Simultaneous game. Then after already we studied the sequential games, and in nature sequential game is possible or not possible, just you imagine and trivial check. Here the simultaneous game comprises with the bimatrix or payoff matrix. What do you mean by simultaneous game? We know that football or any hockey, you imagine about the simultaneous game. There is no sequence is defined. Any player, if they got the opportunity, then they took his move. There is no rule because it is not a sequential game. Any player can took the move as per the chance. Therefore, simultaneous game carried with the mathematical conditions, and how these mathematical conditions transformed into the payoff, because simultaneous condition definitely we correlate with the simultaneous equation. Is it possible? These are also the part of modeling. We can see here a wonderful transformation of game theory through the mathematics. There is the game, but now for us the game is not just a game, but we see the game through the goggles of mathematics. There are n players. Suppose player 1 has k1 possible moves, another player also has the different moves, another player has also the different moves. Then what we can say about the total number of moves? We can see here the total number of moves is just the product of individual moves. It means k1 of player 1, k2 of player 2, and simultaneously kn of player n. There are these particular moves, total moves. Now, the time of modeling, how the game theory is applied of studying the real world problems, how the game theory is applied for modeling the real world problems, how the application of game theory appears. A interesting paradox we can see here, two prisoners. There are two prisoners. This is the paradox in decision analysis, because they have self interest, because they have two options, confess and silent. Definitely in these two options they will dilemma condition. Either they confess about his crime or they silent about his crime. It's strange, and this theory is studied by Professor John Nash through the Nash equilibrium. If we are talking about the equilibrium, then prisoner's dilemma is the application, is the image of Nash equilibrium. Then how the prisoners decide their decisions? Either they go for silent, either they go for confess, either first one go for confess and another one silent, or the first one go for silent and another one definitely confess. Then the outcome will remain same? Never. Definitely there are vertices of outcomes. It means there are 4 cells. Therefore, the payoff is defined by matrix is defined. Another interesting scene here, the same prisoner's dilemma we have here in the picture, but interesting way. What a prisoner's dilemma, how they decide about the accepting the crime or confess the crime or just silent about the crime, because the outcome is fixed. If they confirmed about the particular decisions, then the rule or legal conditions are there for prison. 1 year, 2 year, 10 year, there are certain criteria is already fixed. Then how the prisoners are taking their actions? Very simple. We see here first one is silent, but second one we can see here betray. Both are silent. The first one we can see both are silent. It means definitely the prison, but for only 1 year. First one select the silent condition, but second prisoner not silent but just contradict, betray. Then you can see the second prisoner free, but first prisoner facing the particular decision, 20 years of jail. Next we can see first one, select the silent, and second one, betray. Then we can see here the second prisoner is free, but first prisoner go for jail for 20 years. The fourth condition, first prisoner for betray and the second prisoner just opposite, that is the both, no, same condition. Then we can see the first row and the last row are going the similar decision, but the second and third row for the contradictory decision. We can see both are facing the jail for 5 years because both are going for betraying. This is the wonderful case study of dilemmas of prisoner, how they face the silent, how they face the betray. This is the depending conditions and confess and silent way we can define the prisoner's dilemma. But where is the mathematics? How we can deal this problem through mathematics? The same thing is defined here, presented here in the simpler form. We can see prisoner A and we can see prisoner B. There are two options, confess and remain silent. The first row, there are four cells comprising with the matrices or array. The first cell refers the A11 first row and first column. The green one refers the first row and second column. Therefore, A gets 2 years for the prisoner A as the remain silent, and B gets 2 years for prisoner B again for remain silent. It means we have two values, 2 and 2. Just the coordinate system, we define these elements, these informations in 2, 2, simple coordinate. Therefore, 2 belong from A and the another 2 belong from prisoner B. Second one, first row, A gets 8 years defined for 8 and B gets 1 year for 1. Therefore, the payoff will be 8 and 1. Similarly, the purple one 1 and 8 and the red one 5 and 5, because we see the diagonal conditions are the same conditions, silent and silent and confess and confess. But the another elements, the another payoff represents the contradictory decision. These all are defined in linguistic or simple array type presentation. It does not define a matrix, but the same thing can transform into the matrix. We can see the previous or preceding information transformed into the payoff matrix or bimatrix. In previous lectures, already we defined the basics or basic computation of payoff matrix, but here the case is different. Cell 1 carried 2, 2, just the coordinate geometry, 2 for player A and next 2 for player B, and the element A21, it means first row and second column, it means 8 1, 8 for player A and 1 for player B, R for remain silent and C for confess. The previous information is just transformed into the payoff matrix. Therefore, it is a very interestingly define the matrix into the form of computation. It is a simple model. Again, another model, Snowdrift dilemma. In very simple case, we can see everywhere in Himalaya or in Simla or any particular snow area, we can see the roadblocks by the snowdrift. It means there are two conditions. First, each one of the another side, one side of the snowdrift and another side of snowdrift, what they can do? Either they face the cooperative condition or they face non-cooperative condition. What do you mean about this snowdrift dilemma? There is snow, therefore, both are facing the problem because the transport is stopped. Now, how transport can transform into the continuity? How these two passengers are solve this snowdrift problem? Either they support to each other or they only think about their own solution, not the other one. It is definitely a condition. We cannot guess about the natural decision of both passengers or both travelers, because snowdrift we cannot control about the snowdrift, but the thought are maybe same or maybe conflict about the both sides. Then this is again the game theory application, because there are the decisions, similar decisions or conflict decisions. Again we can transform this through game theory model. Next one, a very simple or economical example here, the illustration for buyer and seller. There are two bags, definitely we are paying some amount for the particular good, but definitely in the bag that good is there. If suppose we pay the amount, but there will be not that good. It is also possible if we do not pay the amount, but they will provide us the good. It means suppose there is a jewelry and the amount of the cost of the jewelry is 2 crore. Suppose he offered that jewelry, but we do not offer the real amount just because that is the closed bag. Again here we can see the 4 situations. In the diagonal there are same situations and other payoff matrix, payoff element facing the contradict or conflict decision. We can see here whenever we are facing the probabilistic decision or the chance of uncertainty or certainty, therefore, the cooperation and defect, nothing, the natural phenomena of studying this type of cases through game theory. This also will applied the conditions of payoff matrix, then by default we study this problem as the game theory. Then again we resume our problem, the prisoner's dilemma. 2 suspects are arrested. We know that they are separated by the police and each given the opportunity to testify against the other. There are 2 options, either they defect or the silent. According to these decisions, the legal action to be taken. Then what to do? How the prisoners can decide their decisions? Either they go for defects or for silent, because there are the resultant outcome, there is the jail or there is free. How this dilemma can solved through game theory? The simple example of algebraic representation. There are the linguistic information about the 2 prisoners. but these linguistic informations are transformed into the algebraic condition. There are the polynomial, it requires the variables and constant. First we deal the variables. X for the Bob defects, the prisoner A is named by Bob and the another one is Steve. The Y for the probability that Steve defects, but here Z is Steve's expected value, because definitely there are outcomes, but how the outcomes is defined? Here constants. Now how the rule of constant? There are variables also, there are constants also. There are 4 constants A, B, C and D. What are the sequence? A greater than B greater than C greater than D, or A greater than C greater than B greater than D, or C greater than D greater than A, B, or B less than A. What are the chaotic condition here? This is study really by the Professor John Nash, and this is the equilibrium. A greater than B greater than C greater than D is the Nash equilibrium, but the outcome is there, then Nash equilibrium is defined. If not, then Nash equilibrium does not define. Therefore, A, the constant, the defection reward, is score for a player defecting when opponent joins. Now we hear the B, the joining reward, is score for a player when both join. There are C and D also we can see here. Very simply, an expected value function Z of x and y is Steve's perspective. What is the Steve's perspective? Depend on the probabilistic function. Thus, Z is defined for the probability that both defect multiplied by the defection punishment. Definitely the outcome is punishment. Either punishment is going to free or punishment is some years jails. What do you mean? If there is no punishment, it means there is the definitely the probabilistic case exists, plus probability that Bob defects and Steve joins multiplied the join punishment, and similar on all the 4 cases. This is the simple polynomial x y, the probability of x and the prisoner A and prisoner B with a constant C. Second one is the positive probability x, and next one 1 minus y is the defect, it means for D. Therefore, x 1 minus y, second one y 1 minus x A for the prisoner constant A, and last one is again conflict, first one and last one. First one is the both silent and last one is the both confess, x y into C and 1 minus x 1 minus y into B. This is the polynomial. We simplify the polynomial, but here we introduce the Steve chooses the defect. It means the value of y is 1. If we put the value of y in equation previous equation, then we found this equation. Similarly, if the value of y putting 0, and again if the value of y putting 0, then the previous equation transformed into the dx minus bx plus b, putting the value of y equal to 1 of the preceding equation and the putting the value of y equal to 0 in this, we have this equation. But now Nash equilibrium, already there are sequence defined on constant A, B, C and D, B greater than A, C greater than D, D greater than A less than B, B less than C. This is the dilemma, this is the condition, these are the situations, but not these all situations are carried in the Nash equilibrium, but A greater than B, B greater than C and C greater than D is the Nash equilibrium. Can we found the same equilibrium in the prisoner's dilemma case? We can see simply applying Nash equilibrium. There are 2 conditions, dx minus bx greater than cx minus ax plus a, or the same thing we written in the left hand side all the x constant and variable term, and the right hand side is only the constant term. After solving for the only the value of x, the variable x, one side the value variable x and another side is the constant, then finally we can see here a minus b in the second term, the cancelled, then d minus c greater than 0, and finally d greater than c. Oh, it's contradict, d greater than c, but Nash equilibrium is defined the c greater than d. What is the problem here? Nash equilibrium, again I resume on the concept a greater than b greater than c greater than d. It means the sequence of a and b and a, b, c and d, but here a, b, d greater than c. How is this possible? It means the Nash equilibrium does not exist here. Prisoner's dilemma is defined in this conclusion, a greater than b greater than d greater than c. It means definitely this is the dilemma, but it does not define with the Nash equilibrium, because a greater than b greater than d greater than c sequence did not form here. Therefore, the Nash equilibrium does not define here. Therefore, we have the probabilistic value by the putting the value in the general form of the probability, and we have the resultant value as the outcome. Therefore, game theory is just not the game, but through the probability, through the mathematical modeling, through the understanding of the algebraic aspect, we can study each and every game through the mathematical beauty, through the understanding of the outcomes. This is the great understanding of the real world, through not only by the game but by the outcomes as the numerical value for the approximation and for the optimal solution. Thank you.